So we have two forces. What we will compare now is the universal force of gravity and the Coulomb's law, Coulomb electrostatic force, which is Coulomb's law. So when we take a look at the universal force of gravity, we'll have G mass 1 mass 2 over r squared. And when we take a look at the Coulomb's law, we will have K Q1 Q2 over r squared. So both of them, as a similarity, has that they are direct proportion to the product of the masses or direct proportion of the product of the charges. They are direct proportion of the inverse squared of the distance, both of them of the distance. So when we are graphing those relations into a graph that has force versus distance, and this will be force of gravity versus distance, and this will be electrostatic force, magnitude of it versus distance. What you will see will be a graph that looks like this in both cases. So it's a graph that is direct proportion to the inverse square of the distance. And this is a graph in which both axes, the vertical axis and the horizontal axis, both axes are asymptotes. So asymptotes. Asymptotes means that they go very close to the line but never touches the line. So this is telling us that when an object has a charge, it doesn't matter how far you are placing it, still will be a small effect on the other charges that they originally probably were close. So this is saying about the force, either of gravity or electrostatic force, will exist no matter how far you are putting two charges. Far apart, you are putting two charges. So will be very small, but we will not consider. So never touches those two axes. However, we do not work with a force like this or a graph like this on physics. We always try to make it as a straight line. It's the nature of the science that will make this as a straight line. So this will be kind of a review from Physics 20, and then we will apply that knowledge and that review, that concept on the electrostatic force. So what do we have here is the force of gravity is the universal constant of gravitational constant, mass 1, mass 2. You probably remember this from Physics 20, but still, it's okay. If I rewrite this in a different form, so if I say, okay, I will write it as capital G M1 M2 times 1 over r squared. Mathematically, I'm not doing anything wrong. Mathematically, when you multiply two fractions, you multiply numerators, and when you are multiplying anything with 1 is the same thing, and you multiply denominators, so will be the same thing. But by doing so, what I give myself is I see now this expression 1 over r squared as a new x. I transform the horizontal axis so that I can see it as a straight line. So now the universal force of gravity can be expressed as capital G mass 1 mass 2 times whatever is this new x that we have in the horizontal axis. So what does that means is that I am making this relation that was an hyperbolic relation, as you saw it here, that both axes are asymptotes to the graph, into a straight line, because a straight line is mx plus b. Okay, when you see a straight line, the equation of a straight line is mx plus b. In this case, b is equal to 0. M, or the slope, is equal to whatever is the product of G M1, M2, and the X is this capital X, which actually is 1 over R squared. Okay, so when we are graphing this, into the axis, we will have the universal force of gravity, and instead of just R that we had before, we'll have that new X, which actually is 1 over R squared, and the graph will be a straight line. And in this straight line, the slope will be capital G M1, M2. So exactly the same logic we'll use for electrostatic force. So we have the to straighten the line, to straighten the graph, the electrostatic force that is represented as KQ1, Q2 over R squared. To give ourselves the liberty to say that, oh, this is what X will be, this is what will be in the horizontal axis, we rewrite it as KQ1, Q2, 1 over R squared. And then we say that, okay, so now if I assign this with a new X, if I modify the horizontal axis into squaring up and inversing it, then I can write the electrostatic force as KQ1, Q2 times this new X, which actually is very similar to the equation of a straight line. Y is equal to mx, where y is the electrostatic force, x is this 1 over r squared, and slope is kq1, q2. Having a straight line, because the y-intercept is equal to 0. Having a straight line means that we will modify now the axis, the vertical axis still being FE, but the horizontal axis is 1 over r squared, and then the line is a straight line, and on this straight line, the slope will be KQ1, Q2. So if we have data given, then usually what the information that is given is something like the distance in meters and electrostatic force in newtons. And then what you will do is, in order to have a straight line, you will create 2 more columns. You may create only 1, but 2 more will be. You will square root this, so you will take all those values and square up them, and then you will take the inverse of it. And what you will do is you will plot those values as x or in the horizontal, and those other values on the y, or on the vertical axis, and then you should have a straight line. Now, the slope can be physically calculated because what slope is delta y over delta x. Okay? And this slope, you do know now from the logic and the concepts that we treated in prior, is equal to k q1 q2. So you will be able to calculate this, to physically calculate this value. So you will have, meaning that you will have a number, and that number, slope, will be k q1 q2. From here, you can find that the experimental value of k will be whatever is that numerical value that you found for the slope over q1, q2. The last thing that we will see in comparison to the force of gravity, m1, m2 over r squared, and electrostatic force or Coulomb's force, Coulomb's law, call it whatever you want, is that this is in terms of magnitude. When we are talking about the type or the nature of the force, the universal force of gravity is always attraction, and the electrostatic force is both attraction and repulsion, dependent on the nature of the charges. If the charges are opposite, then it's attraction. If the charges are the same, then it's repulsion. This is pretty much what you need to know in terms of like the relationship, what is the same and what is different in terms of the universal force of gravity and Coulomb's law.